Hello everyone, I welcome you all again in this video series in which we are discussing about the machining processes. And in the last video we have discussed about that different how the different types of the forces that we are using the turning operations that is converted into the main cutting component, that is FC, and perpendicular to that is FT, that is thrust force. And after that, once the conversion is takes place, then how we can calculate the remaining forces that we have already calculated or we have already derived for the orthogonal cutting by using the merchant theory. Okay, so in this video basically we are going to discuss about the tool wear and the tool life, and we'll also discuss about the calculation if we get the time. So tool wear, wear is basically when there is a loss of the material. Okay, so in whole machining process basically the loss of the material is there, but in this video basically, or in this line basically, we are discussing about the tool wear. So whatever the loss of the material or the material which is removed, not from the workpiece but from the tool. Okay, so you can ask that if we are using the tool, then how the material is removed from the tool itself, because tool is also a material. Okay, by the way, the tool has a very high hardness comparatively with the workpiece material. Okay, but still there are number of parameters, like we can say that there are feed is the main, feed is the parameter, depth of cut is the parameter, rotational speed, velocity, cutting speed. So these are the few of the parameters. So that will affect the loss of the material. Now, when loss of they will affect the loss of the material means loss of the material means this will affect the rise in temperature also, the rise in temperature. Now, how this temperature will affect? Like this is basically, you just treat it as a single point cutting tool we are making through this billet. So this is basically the side. This means this is the front side. So we can say this is the end portion. Okay, and this is the side, and this is the rake face. Okay. Now we have already seen how to make this geometry of a single point cutting tool using the rubber prototype. Okay, so whatever the chip that is coming out over this surface, or we can also use this diagram. Okay, so if we are using this one, we are moving towards this side and the chip is coming out like this. So this chip is basically coming out. This is basically the rake surface, and this is the clearance face or flank face, or the what we can say, there is another one more term is there. So this is the clearance angle and this is the rake angle. So this chip is coming out over the rake face. Okay, and when this chip is coming out over this rake surface, this will basically travel. Now first we can talk about the means here basically we are talking about the continuous chips only. Okay, if I'm talking about the continuous chips, it means we are talking about the ductile material. Okay, now if we are saying that we are using the ductile material, because in case of the ductile material only, this chip will be continuous, and when it will be continuous, it will rub over the surface of this tool. Okay, because this is the continuous flow of that chips. Now when it will continuous flow, there will be rubbing between this tool and chip interface. Because of the rubbing, the temperature is increases, and because of that the heat is increased. Heating takes place between the tool and the chip. Now because of this heating, the welding, sometimes it happen that welding is also takes place at this region. And because of this welding basically is it will the surface, whatever the surface, or it will become a wave shape over here, so that what it is, this tool is continuously moving in this direction for the cutting purpose. The chip is coming out. So what will happen that sometimes when the wave shape is large enough, it will come outside along with these chips, and again the rubbing is start. So because of that the temperature is continuously generated. Okay, and because of that sometimes it happen that when this weight shape is coming out, sometime it happen that the material which is material of this tool, which is also at very high temperature right now, and that is about, if the welding is takes place, it means that the material is about to melt or it has been melted. So that is also coming out along with these chips or whatever the wave shape that is traveling outside from this region. Okay, so this is basically occurs at the rake phase, because everything you can see that this is the rake phase occurring at this rake phase only. So we are treating like this region is basically the crater wear. At this, the crater wear occurs. Okay, now these are the conditions. Generally it is occur for the ductile material only, and it will occur the rake at the rake phase only. Okay, so please keep in mind that okay, I have started. Tool wear is basically of two types. First is the crater wear, but means most of the wear come under these two category only. Okay, so this is the crater wear, and second is basically the flank wear. Flank wear. Okay, we also call this one as a wear land. Okay, now so crater wear is which is occurs generally when the continuous chip is generated, and which is occur on the rake face of this tool. Okay, now when we are going for the cutting purpose, most of the time we are using this side face only, or sometimes we also use this for the facing purpose and end face. But what will happen is this will be in continuous, like if we talks about okay, so sometimes what happen that through this side basically I want to show you. So what will happen that as we are moving toward this side, is this face is continuously rubbing over the machine surface. Okay, so if generally it is not rubbing, basically it is it happens sometimes that the material when the removed, if it is not means the strength of the workpiece is not matching, means it is generally in the specific ratio that strength of the tool and the workpiece should be there. But if it is not in the specific ratio, then sometimes it occurs that if the hardness of this or carbide particles is present in this workpiece material, then it is not completely clean, or this surface is not smooth. Sometimes the weight shape particle should come out along with this machine surface. So what will happen because of that, usually we are keeping this we are machine our tool before going for the machining purpose of this workpiece. But what will happen if these carbide particles should be there, then or high temperature is already there, because of that the material, because you have already seen that in a single point cutting tool the nose is of almost zero point 0.7 mm or zero point 0.8 zero point 0.5 mm. Okay, that is in the range. So what will happen if we are going for a continuous machining purpose for that, then the nose or the side cutting edge will become like this. Okay, so because of that what happened that is the tool is already posted over the tool post. Okay, so that we cannot move for during the process like this in this direction, so we have to hold it. So what will happen, the initially what the depth of cut we have chosen, and finally what we will get after that. Okay, means once this operation is done in a single pass. So we have to keep in mind that this flank wear should occur over these surfaces. Okay, and sometimes it is occur on the end face as well. So this is basically the flank wear, which is occur on the clearance face, flank wear, and this is basically the crater wear. Okay, there are different types of the mechanism that I have already told you that there are different types of the mechanism also available, like plastic deformation, chipping, the the chipping as well as this plowing operations. So these are basically the mechanism through which if we'll keep these parameters in safe side, the material removed from this workpiece also from the tool is less. So whatever the if we have to keep in mind to increase the tool life, then we have to keep these parameter in the range only. Okay, so this is all about the tool wear. Let's move to the tool life. Now, if we when we talk about the tool life, there is a researchers that is Taylor's, okay, which has presented the equation for the tool life basically. Okay, and tool life, if we are talking about, then what is the meaning of life is that how much tool will be there, okay, for the different parameters, whatever the parameters that we are using or for the machining purpose we are using. So for that, basically the Taylor's was the scientist that was invented one of the equation. So this equation is basically Vt raised to n equals to constant. What these parameters are, what the meaning of these are. V is basically the cutting speed. Okay, so this cutting speed that is always here is calculated in meter per minute. Okay, and T is basically the time. Okay, or the tool life also we can say. So this tool life is calculated in the minute. Now if we are saying that tool life is calculated in the minute, it means that when you will purchase the single point cutting tool from the market, they will ask you, you will get to know that a single point cutting tool life is like, if we are purchasing of HSS, then there is a whatever the life they will give you, like 100 minutes, 200 minutes, 300 minutes for the different material. Okay, so this tool life T is basically given as per that. Okay, and there are two parameters. First, n is basically the exponential constant. Okay, this is basically the exponential constant. Okay, and C is basically a constant only. Okay, now if this is the equation, then there are three generally this question has been asked for generally for the three material. One is for the HSS, that is a high speed steel, carbide, okay, and the ceramic. Now the value of these value of n, basically n depends on the material properties. Okay, so the value of n for the HHS is in the range of 0.08 to 0.20. Okay, the value of n for the carbide is belongs to 0.20 to 0.40. Okay, and the value of n for the ceramics varies from 0.50 to 0.70. Okay, so these are the values for the n. Now if we are saying that there are three different material we are using, then the life this V and T, this will be like sorry, this is V and this is T, two life. So this will be like graphs for these will be like this one. Okay, because Vt raised to n equals to constant. So if you will make the graph between V and T, then this graph will be like this. These are the value of n. This is for the HSS, this is for carbide, and this is for ceramic. Okay, so as the n value is increasing, this graph is also increases. There's a one more terms is there that means there is another way to solve this graph, because sometimes we also use that this relationship is not a curve, basically it is a linear relationship. So how it will come a linear, when you will take the ln both the side, okay, or the log both the side, then this equation will become ln v into t raised to n equals to ln c. Okay, now this is basically ln a into b. So ln a into b will be ln a plus ln b. Okay, so this will be ln v plus ln t raised to n equals to ln c. So this will be ln v plus n into ln t equal to ln c. So when you will take this this value in this direction, so it will be ln v equals to minus n into ln t plus ln c. So this equation will be y equals to mx plus c. In the x direction we are taking this ln t, and y direction we are taking this ln v. Okay, so this is basically the ln v and this is ln t. So this graph, because this m, that is in negative direction. Okay, this is minus n, the slope of this curve. So this will be like this equation will be this line will be, the graph will be like this. Okay, so when we are taking this one for the HSS, this will be like this, and when the value of n is increases, it will increases like this. Okay, so for this as well, this is for the HSS, this is for the carbide, and this is for ceramic. Okay, and one more thing is that in the last video, in the last slide, basically we discussed about the tool wear. So tool wear was depends on the feed, depth of cut, V, and rotational speed. Okay, so here again, the Taylor's basically he modified his equation, and he invented another equation, that is V T raised to n F raised to A, F raised to A, and D raised to B, that is equals to constant. इसका मतलब क्या है बेसिकली कि अगर यहाँ पे भी कांस्टेंट यूज किया है कि लाइक कॉन्स्ट, अगर पूरी इक्वेशन ही कांस्टेंट है, इसका मतलब ये है कि मान लीजिए कि टू लाइफ और कटिंग स्पीड जो होती है, टू लाइफ होती है, जैसे मान लीजिए टू लाइफ है, तो एक अगर मैं एचएसएस की बात करूं तो उसके लिए टू लाइफ मतलब आप कोई भी मतलब एक अगर स्पेसिफिक मटेरियल है, एचएसएस है, तो उसके लिए टू लाइफ कांस्टेंट होगी, कार्बाइड है तो उसके लिए टू लाइफ कांस्टेंट होगी। तो इसका मतलब क्या है कि अगर पूरी इक्वेशन कांस्टेंट है, तो इसका मतलब ये है कि आप इन वैल्यूज को दो अलग अलग टूल्स के लिए कंपेयर कर सकते हो। मींस अगर आप ये इक्वेशन आप एचएसएस के लिए लेते हो, तो सेम इक्वेशन को आप इक्वेट कर सकते हो फॉर द कार्बाइड एज वेल। ओके, क्योंकि overall whatever the value you will get, that is v into t raised to n, that will be equals to constant। okay, तो दोनों इक्वेशंस को आप कंपेयर कर सकते हो। Similarly for this one, that v, that is cutting speed, t, that is in meter per minute, sorry, meter per minute, this one, and this is minute to life, that is in minute, feet, that is mm per revolution, and depth of cut, that is m, that is in mm. Okay, and again that is the exponential constant, and a and b are again a constant। okay, so that will be equals to the constant again, that is c। okay, तो ये जो है आपका मॉडिफाई इक्वेशन है, एंड दिस इज फॉर द टेलर्स इक्वेशन। तो मोस्ट ऑफ द टाइम तो जो न्यूमेरिकल्स होते हैं वो आपके इसी इक्वेशन से सोल्व हो जाते हैं, सो देयर इज नो नीड टू गो फॉर दिस इक्वेशन, बट समटाइम्स इन द प्रॉब्लम्स द वैल्यू ऑफ फीड एंड डेप्थ ऑफ कट इज आल्सो गिवन, सो वी हैव टू यूज दिस पैरामीटर्स। ओके, so this is about the tool life, so let's move to the calculation part। yeah, this we have already discussed। okay, so let's move to the problem। So in a single point cutting tool, cutting turning operation, basically this question was asked in the IAS 1995। in a single point single point turning operation with a cemented carbide and steel combination having, means this tool is basically made up of the combination of cemented carbide and the steel। okay, and the Taylor exponent means value of n is given, that is 0.25। okay, the value of n is given to you, that is 0.25। okay, if the cutting speed is half, okay, then the tool life will become। now देखिए इस इक्वेशन, इस तरह के क्वेश्चंस को हमेशा सॉल्व करने के लिए आप क्या करिएगा, सबसे पहले जो डेटा आपको गिवन है वो लिख दीजिएगा, और जो डेटा समझ में ना आई है उसको छोड़ दीजिएगा। ठीक है, उसके बाद क्या करिएगा कि इक्वेशन क्या है, हमेशा जब भी आपको टूल लाइफ कैलकुलेशन करना होगा, दैट टाइम यू हैव टू यूज दिस इक्वेशन, दैट इज v t raised to n equals to constant। ओके, नाउ इसमें क्या पूछा है कि इफ द कटिंग स्पीड इज हाफ, अगर कटिंग स्पीड को हाफ कर दिया जाए तो टूल लाइफ क्या होगी। इसका मतलब क्या है कि इनिशियली देयर वाज सम कटिंग स्पीड, सेकंड जो कंडीशन है उसमें क्या कर दिया कि आपने कटिंग स्पीड को आधा कर दिया है। ठीक है, तो इसका मतलब हम ये कंसिडर कर लेते हैं कि फर्स्ट देयर वाज द v1 एंड t1, मतलब अगर कोई वेलोसिटी होगी v1 तो उसके करस्पॉन्डिंग जो उसकी टूल लाइफ होगी दैट इज v1। तो मैं इस इक्वेशन को ऐसा लिख सकता हूं, दैट इज v1 t1 रेज़ टू n इक्वल्स टू कांस्टेंट। देखिए n की वैल्यू क्या होगी, हमेशा सेम रहे, मतलब वेरी हो सकती है बट इट डिपेंड्स, क्योंकि यहाँ पे क्या है कि आपको सिर्फ कॉम्बिनेशन दिया हुआ है, आपको दो अलग अलग टूल नहीं दिए हैं। ठीक है, सो प्लीज कीप इन माइंड। सो फर्स्ट कंडीशन ये हमने मान ली। ठीक है, अब दूसरी कंडीशन हम मान लेते हैं कि जो वेलोसिटी है दैट विल बी v2, तो अलोंग विद जो टूल लाइफ होगी दैट इज V2। तो इक्वेशन क्या हो जाएगी, दैट इज V2 इंटू T2 रेस टू n इक्वल्स टू कांस्टेंट। ठीक है, तो अब देखिए दोनों इक्वेशन, इक्वेशन नंबर 1 और इक्वेशन नंबर 2 में क्या है कि दोनों इक्वेशन जो है वो बराबर है, किसके बराबर है, C के, मतलब दोनों की वैल्यू जो है वो है कांस्टेंट, मतलब कोई एक वैल्यू होगी जो दोनों के बराबर होगी। ठीक है, तो इसका मतलब क्या है कि हम दोनों इक्वेशंस को इक्वेट कर सकते हैं। ठीक है, तो V2 V1 T1 रेस टू n इक्वल्स टू V2 T2 रेस टू n। ठीक है, अब देखिए कि जो कंडीशन गिवन है दैट इज n की वैल्यू आपको 0.25 गिवन है एंड कटिंग स्पीड इज हाफ। इसका मतलब क्या है कि सेकंड टाइम में जो आपकी V2 है वो पहले के कंपैरिजन में आधी हो जाती है, दैट इज हाफ हो जाती है। तो आपकी टू लाइफ क्या होगी, मींस T2 आपको पूछा है इन टर्म्स ऑफ T1 कितना होगा। ठीक है, तो देखिए V1 और T1 को एज इट इज रहने दीजिए, n की वैल्यू को रख दीजिए दैट इज 0.25। ठीक है, V2 कितना है, दैट इज V1 बाई 2 और T2 क्या है, T2 तो हमें कैलकुलेट करना है इन टर्म्स ऑफ T1, तो इसकी वैल्यू को रख दीजिए दिस वन। सो दिस विल बी कैंसल आउट फ्रॉम बोथ द साइड्स। ठीक है, मैं यहां से क्या कर रहा हूं, इक्वेशन से T2 बाई T1 की वैल्यू फाइंड आउट कर रहा हूं। ठीक है, अगर मैं T2 बाई T1 की वैल्यू फाइंड आउट करता हूं तो इस इक्वेशन को क्या करना पड़ेगा, ये जो टर्म है मुझे इसको इधर लाना पड़ेगा T2 के नीचे, और ये वाली जो टर्म है मैं उसको इधर ले आता हूं, तो इसको ले आऊंगा तो T2 बाई T1 रेस टू 0.25 इक्वल्स टू कितना आ जाएगा आपका 2। ठीक है, नाउ जब इसको आप रिवर्स करेंगे पावर, तो दिस विल बी, दिस इज T2 by T1 will be equals to 2 raised to 1 by 0.25। तो 1 by 0.25 कितना हो जाएगा, 100 by, so this will be 4, 2 raised to 4। ठीक है, 2 raised to 4 कितना होता है, that is 8। okay, so T2 will be equals to, from this equation T2 will be equals to 8 times of T1। तो टू लाइफ कितनी हो जाएगी, when the life at this exponent value of n, if the cutting speed is become half, then the tool life will become 8 times, so the option will be C। ठीक है, लेट्स मूव टू द नेक्स्ट वन। तो बेसिकली इसमें मैंने 4 से 5 क्वेश्चन रेड किए हैं एंड दे आर बेसिकली जो उनका लेवल है वो इंक्रीज हो रहा है। ठीक है, तो दैट वाज द इजीएस्ट क्वेश्चन। Six, next question. Using the Taylor's equation, that is Vt raised to n है यहाँ पे, sorry, Vt raised to n equals to constant. Calculate the percentage increase in two life। देखिए परसेंटेज इंक्रीज इन टू लाइफ, ठीक है, हमें कैलकुलेट करना है व्हेन द कटिंग स्पीड इज रिड्यूस्ड बाय 50%। देखिए पिछले क्वेश्चन में भी क्या था कि हाफ था, और हाफ का मतलब क्या होता है, 50% ही होता है, बट n की वैल्यू हमें 0.25 दी हुई थी, यहाँ पे n की वैल्यू 0.50 गिवन है और c की वैल्यू भी हमें यहाँ पर गिवन है। ठीक है, तो हम क्या करते हैं, सबसे पहले जो वैल्यूज गिवन है उसको लगते थे। पहले तो हमें इक्वेशन भी गिवन है दैट इज Vt रेज़ टू n इक्वल्स टू कांस्टेंट। देखिए फर्स्ट कंडीशन के लिए हम लोग मानते हैं कि जो कटिंग वेलोसिटी एंड द टू लाइफ है दैट इज V1 T1। सेकंड कंडीशन के लिए इट विल बी V2 T2। ठीक है, तो देखिए पहली इक्वेशन को जब हम लिखेंगे फर्स्ट कंडीशन के लिए, तो दिस विल बी इक्वेशन, दिस इक्वेशन विल बिकम V1 T1 रेज़ टू n इक्वल्स टू कांस्टेंट। देखिए अब n की वैल्यू भी कांस्टेंट है दोनों कंडीशंस के लिए और c की वैल्यू भी कांस्टेंट है, तो मैं इसको ऐसा लिख सकता हूं दैट इज V1 T1 रेज़ टू 0.50 इक्वल्स टू 400। ठीक है, और सेकंड कंडीशन के लिए जब इस इक्वेशन को यूज करूंगा दैट इज V2 T2 रेज़ टू n इक्वल्स टू कांस्टेंट, सो दिस विल बिकम V2 into T2 raised to 0.50 equals to 400। ठीक है, अब देखिए इसमें क्या है कि आपको क्या बोला है कि दिस कटिंग स्पीड इज रिड्यूस्ड बाय 50%। तो कटिंग स्पीड कितना हो जाता है, 50% हो जाता है, दैट इज V1 by 2 हो जाता है। ठीक है, मींस 1 by 50, 100 by 50। ठीक है, सो दिस विल बी या V1 by 2। ठीक है, तो अब क्या है कि देखिए पहली जो कंडीशन है कि परसेंटेज चेंज इन लाइफ कितना होगा, परसेंटेज चेंज इन लाइफ कितना होता है, हमेशा चेंज इन लाइफ जो फाइंड आउट करना है दैट इज T2 कितना चेंज हुआ, कितना चेंज हुआ, दैट इज T2 माइनस T1 विद रिस्पेक्ट टू इनिशियल इनटू 100। ये होता है आपका चेंज इन लाइफ, ये आपको कैलकुलेट करना है। सो व्हाटएवर द वैल्यू यू विल गेट इट हियर x, दैट विल बी इन परसेंटेज। ओके, तो ये हमें कैलकुलेट करना है। तो हम क्या करते हैं कि देखिए या तो देखिए हम हमारे पास एक ही ऑप्शन है। ठीक है, कि इंडिविजुअली क्या करेंगे, हमें V1 की वैल्यू दी होती तो हम यहाँ से T1 निकाल लेते हैं। ठीक है, और V1 की वैल्यू दी होती तो यहाँ से V2 भी पता लग जाता और यहाँ से T2 निकाल लेते, फिर हम कैलकुलेट कर लेते हैं। बट हमें ना ही V1 दिया है ना ही T1 दिया है, तो हम क्या करते हैं कि दोनों इक्वेशन को इक्वेट कर देते हैं। जब दोनों इक्वेशन को इक्वेट करेंगे, दिस विल बिकम v1 t1 रेस टू 0.50, दैट विल बी इक्वल्स टू v2 into t2 रेस टू 0.50। ठीक है, ये इक्वेशन आ गई। नाउ हम लोग क्या करते हैं, यहाँ से T2 by T1 की वैल्यू फाइंड आउट कर लेते हैं। तो T2 by T1 रेस टू 0.50, पहले तो ये हो जाएगा। दिस विल बिकम, आप इस वैल्यू को इधर लेके आए हैं तो इसको इधर लेके जाना पड़ेगा। सो दिस विल बिकम V1 by V2। ठीक है, अब V1 और V2 कितना है फ्रॉम दिस इक्वेशन, दिस विल बी V1 by 2, तो इसको मैं ऊपर ले आता हूँ। ठीक है, सो दिस विल बी ट्वाइस। नाउ यहाँ से आप T2 by T1 की वैल्यू निकाल लीजिए। T2 by T1 विल बी इक्वल्स टू 2 रेस टू, देखिए पावर है 0.50, तो पावर जब रेसिप्रोकल करेंगे तो इट विल बिकम 1.1 अपॉन 0.50, सो दिस विल बी 100 and this will be 2, so 2 raised to 2, so this will be 4। okay, now इस इक्वेशन से this will be T2 minus T1, sorry T2 by T1 minus 1 into 100, so T2 by T1 कितना है आपका 4 minus 1 into 100, so this equation answer will be 300 in percentage। okay, so when you will use the value of n, that is 0.50, c से कोई फर्क नहीं पड़ रहा है यहाँ पे। when you will use this equation, means value of n will be 0.50 and the life is reduced to 50%, then sorry, cutting speed is reduced to 50%, then the change in tool life will be 300%, so the option will be A। okay, so in this video we are stopping up to here. In the next video we'll go for the next numerical problems. Thank you so much guys.